Hey everyone, this is Mr. Chandro. I'm here with a financial algebra video. We talked about this in class on Tuesday, but I thought I would make a little video just to go over the open-ended questions that were in the diagnostic exam, since we might not have had time to discuss everything in class. So I just want to take a few minutes and go over these open-ended problems, just so you guys can listen and take notes on your papers that you received in class too. So let's go ahead and get into it. So I'm starting right here on number 31. So by the way, so when I'm making this video, I'm kind of assuming you guys have tried the problems on your own and you've read through them a little bit. So I might not read all the problems out loud. I might just hop straight into some explanations. So if you need to, just go ahead and pause, and you can just go ahead and resume when you're ready to learn more about the problem. Okay, so let's look at this first one. I like this first one. This is kind of just a little bit of Algebra 1 review. We're going to go ahead and just write a couple equations just based off the word problem. So yeah, we just got a pretty simple problem right here. So we had to go ahead and write two equations for Jude and Ringo. So it says Jude starts with $200 in a savings account. So we're basically just going to make two separate y equals mx plus b equations. So if you're already starting off with 200, I just put plus 200 for Jude, and they're saving $25 each month. So we just get a nice y equals 25x plus 200. So in other words, every time 1 month goes by, they're going to get 25 bucks. So if x equals 1 month, they're going to have $25. If x equals 2 months, they're going to have $50, so on, so on. So we have y equals 25x plus 200. Same thing for Ringo. It's going to be the same thing. So he's starting with 100. And then his savings, or I'm sorry, he'll save $50 each month. So you get y equals 50x plus 100. Hopefully that makes sense. And then just a little bit of review on y equals mx plus b. So when we have y equals mx plus b, let me go ahead and write that in. Y equals mx plus b. Remember, m is the slope, b is the y-intercept. So if you're able to write an equation like these, you can just go ahead and graph them pretty quickly, which is nice. So the part B is asking you to graph the equations on the same set of axes. So for y equals 25x plus 200, I just put the y-intercept right here at 200. Same thing for this one. We put the y-intercept at 100. It says the slope is 25. So what does that mean? That means it's rising 25 and going over 1. So in the problem, he's gaining $25 every month. So we go up 25 over 1, up 25 over 1. So actually, to graph a line, you only need 2 dots. So just for this example, though, I went ahead and I plotted like a couple more just so that you can see where it's going. This is going to be where they intersect right here, both lines. But you can go ahead and just plot your points. I do recommend when you're graphing, make sure and have a really good like straight edge, because then you can just go ahead and make a line pretty easily. So that's our first equation right there. We went ahead and graphed Ringo, so that's a y-intercept of 100. This one's a slope of 50, so we went up 50 over 1, up 50 over 1. So both lines are going to intercept right here. So the question was, how many months will it take for Jude and Ringo to have the same balance? So we just showed in our equations right here, it's going to take about 4 months for them to have the same balance in their account. Okay, so for this next one, the question is kind of based off this graph right here. So we have a graph. It says federal student loan debt by age. This is the amount of debt you have, and this was the age of the people that were in the survey, I guess. Yeah, this is just a sample of people, a sample of 35 borrowers. So I'm just going to refer back to this table during the explanations, but it might not be on the screen. So just make sure you have that when you're watching the video. Okay, cool. So the first part is saying, what does 27 represent in the table? So 27 was just saying 27 of the 35 borrowers had a federal student debt loan between $0 and $40,000. So that one was pretty easy nothing really tricky there. This next one is a little bit weird. It's saying complete the frequency table below. So in other words, what's the percent chance of everything happening? Like, what's your percent chance of being less than 24 years old and having debt from $0 to $40,000? So just for this one right here, everyone in the sample anyways, everyone that was under 24 years old, all 7 of them had a debt from $0 to $40,000. So in other words, if you're less than 24 years old, there's a 100% chance that you're going to have a debt from 0 to 40. That's basically how you calculate all of these. So how did I get 79% right here? It said in the sample, there was 11 people out of 14 were 25 to 34 years old that had a debt from 0 to 40,000. So just to show you guys the calculation real quick on the calculator, this is how you just find a percent. It's really easy. So if I have 11 people in this sample, I'm just going to do 11 divided by 14 people total. So that's how you actually get 79%. So that was my answer right there. So I'm not going to spend too much time on this one, but yeah, you basically just go through and you find the percentage just like I did for that 79%. And then all of these should add up to 100 in each column. So if you have a question about that, ask at the end of the video. There will be a chance for you to do that. Then it says, based on this data, is there an association between age and federal student loan debt? So basically what you see from this table, let me go back to the other side really quick. So what we actually saw is that the older you are, it's actually more likely that you're going to have more student debt. So in real life, I mean, there's a few reasons that might happen. Usually, obviously, younger people are going to college for the first time. As you get older, you might actually start adding in more education or more degrees that you might have to pay for, and you might start accruing more debt. Also, a way you might actually have more debt, even after you are done with college, is if interest starts accumulating on your loan. So that's something that we're going to talk about more this year when we get into talking about loans and taking out college loans and stuff like that. So, okay, I think that's it for 32. Yeah, that looks good. Okay, heading on to the next one, 33. Okay. Okay, this one was definitely a little bit trickier because you had to know some formulas. So again, don't worry about this stuff. This is all stuff that we're going to learn later on in the year. So don't feel bad if you didn't know how to do this one, but I'll walk you through it really quick. So 33 is talking about someone that is thinking about how to invest their money, basically, and they have 2 different investment options. So as you get older, like as you get into college age, adult age, obviously you'll have different investment opportunities, or you might need to figure out where to save your money or something like that. So this is kind of what that process would look like actually right here. So the first part of the problem is just saying she's investing $2,000, and it's saying that there's an average annual growth of 5.5% per year. So for this problem, we needed to know the compound growth formula. So compound growth, what does that mean? That means that every year you're going to earn a new amount of interest based on how much money is in your account or in your investment. Okay. So in the first year, she's basically earning 5.5% of $2,000. But then the year after that, she's going to earn 5.5% of that money. And then the year after that, she's going to earn 5.5% of that money. So that's known as compound growth, because essentially your money, you're going to keep earning interest on the new money that you're earning. So that's a good way to save for retirement. So this is the formula right here. So basically your amount is equal to the principal that you invest. So she invested $2,000. So how did I get this right here? 1.0055. So essentially something really good to know is 1 equals 100%. So how much how much interest does she have on this investment? Her investment is basically growing 5.5% every year. So that's what we write right here for the actual growth. It's 1.055. Because again, how would I write 5.5%? 0.055. That's how, in decimal form, that's how I write 5.5%, like that. So if I just want to write essentially how much money is she getting every year? She's getting 105% of her money. So the way that we write that in the formula, we just write 1.055. Now again, how did I get 18 right here? How many times is her investment going to compound? It's going to compound 18 times if she invests that money for 18 years. So that's the last piece that you put right here. Now, once you have all of this, we can actually go ahead and put that in our calculator. So let's do that. So there's a principal of 2,000 times 1.055. That's the growth rate. That's being compounded 18 times. Once I put all that in my calculator. So even though she's starting with $2,000, after she's invested that money for 18 years, she's actually going to end up with $5,242.93. Okay. Now the next part of the problem is saying she has another investment opportunity just to save simple interest though. What simple interest means is that you just get a fixed amount of interest every year. It doesn't grow in a compounding fashion. Okay. So it says in her first year, she's earning 10% annually. So what's 10% of 2,000? Let's go ahead and use our calculator. 2,000 times 10% is $200. So she's earning $200 every year, basically. So for simple interest, you start with the principal, and then you're going to add $200 for every year that she's investing. So 18 years. In this model, she would actually earn $5,600. Okay. So the simple interest was actually better right there. Now for the last problem, it's just saying, okay, assume that she's doing compound growth over 30 years. Assume that she's doing simple interest for 30 years. Which one is better? After you plug everything in, you can see that the compound interest investment is actually better by quite a bit. About how much more? About $1,900 better. So, okay, yeah. At any time in the video, guys, I'm gonna keep going through these problems. So just feel free to pause and get caught up. I'm just keeping the work there for you. So, okay, let's go to 34. Okay, so this is another problem kind of similar to algebra 1, algebra 2. We just need to go ahead and write a system of equations that covers the conditions that are written out in the problem. So basically this problem is about Jose. He's trying to throw a party and he's trying to keep a certain budget within the prices that are set by the store that he's shopping at. So what is his budget? Let's go ahead and circle this information in the problem. So his budget, we don't exactly know what his budget is. So this is an inequality. So his budget could be, I'm just making these up, but when you're throwing a party, your budget could be anywhere from like $0 to $100 to $150. You don't exactly know how much money you're going to spend. So if you don't know exactly what it is, that's when we use an inequality. So this is basically saying his budget has to be less than 2x plus 3. Where did I get that from? He wants to spend $2 per guest, 2x. And then he's saving $3 to cover shipping. So it kind of like in that earlier problem we did, he's at least going to spend $3. So I just put plus 3 right there. Okay. And then at the store that he's shopping at, it says that they charge a $1 flat fee for all orders. So that's how I got plus 1 right there. And then it's charging 50 cents per bag. So I put 0.5, in other words, 50 cents, 0.5x. Okay. Then it says, which one is correctly modeling the scenario? So I'm not going to get too much into the graphing stuff today because it's not, I think the more important part is being able to write the equation. But I'll just explain which one is the correct graph. So anytime you're doing less than or equal to, that's going to be a solid line. Let me go ahead and write that. This is a solid line. Anytime there isn't that equal to sign right here, that's just going to be a dashed line. So number 3 is the correct answer. So let's go ahead and map these out. So we see 0.5x plus 1. I have a y-intercept of 1 right there. And then it's a slope of 0.5. So I'm going up 0.5 over 1, up 0.5 over 1, like so. So you can see that right there. For the dashed line, it's a y-intercept of 3. So we see that right here. Then it's a slope of 2. So I'm going up 2 over 1. Up 2 over 1. So you can see that slope right here and it's dashed. So now this is saying the budget has to be less than 2x plus 3. So that's why I shade in right here. The ordering has to be greater than this line. So we shade right here. So that's why we see a dark shade right there, because this, basically this section right here is satisfying both equations. Okay. Not going to get too much into this today, but it says, what are 2 possible solutions? So these are just 2 solutions that I picked out of the graph that we have. So one potential solution is 1 and 2. That means if he has one guest, it would cost $2 total. Yeah, I'm gonna go back to that later because that actually doesn't quite make sense. That doesn't fit with our equation, but it's actually in the solution, so that's fine. You could pick that one. Another one we picked was 2 guests and $3 costs. So that also fits in the area of solutions right there. Okay, so that was number 34, and then we just have one more. All right, this one was good too. This was actually very interesting because we've got some good application here for real life. Okay, so this chart is showing age versus earnings. In other words, what do people earn compared to their age? So you can see right here, 20-year-olds, they're making about like 60,000, 80,000. 50-year-olds, they're making a little bit more money, maybe 90,000. 70-year-olds, 60-year-olds, they're up into like the 100,000s. So what is this chart basically saying? What's the basic pattern? It's basically saying the older you get, you're going to make more money in your career, right? Which I think that's generally true for most people. Not true for everyone, because you can see right here, like this person right here, this person is, just in this chart, this person is like 24 and they're making 40,000. This person, let's find another one. This person, yeah, see this person right here is 55. They're making about 60,000. So these are called outliers. Sometimes there's people that aren't right on that line of best fit that we drew, but that's why it's called a line of best fit, because generally it's going to fit most of the data that's in the chart. So this isn't a straight, I can't draw a straight perfect line through all of these points, but we can just it's just called a line of best fit, just that it generally fits most of the data. Okay, so that was part A. It just said sketch the line you think best fits the data. So I went ahead and did that. Describe the correlation between age and earnings. Is it strong or weak? I said there's a moderate correlation. So I said generally as your age increases, your earnings is going to increase too. If it was a negative correlation, it would be going the opposite way, which in real life, that wouldn't really make sense. You wouldn't make less money the farther you go in your career. Typically, you get promoted or you get more experience, so you get paid more. So I said there's a moderate positive correlation. Then it said write your equation. This one is just an estimate, so I just wrote a very basic equation. I said y equals 1x plus 60. So my y-intercept is about right at 60. And then I said 1x because every year that you get older, your salary will go up by $1,000. Okay. So we see like right here at 20 years old, you're making about 60,000. At 40 years old, you're making about 80,000. So it's about 1x. It's about every year you're going up about $1,000. Okay. And then I said that right here for my answer. So in other words, the average income goes up about 1,000 after every year. All right. I think that does it for our first video. Those were the diagnostic exam open-ended questions. So there's going to be a space for you to leave a question at the end of the video. Please do that. And we'll see you in class next time.